Hello, I'm Anke Neumann and I'm chair of the Clay Minerals Group of the Mineralogical Society. And it is my pleasure to welcome you to the 7th CMG Jubilee interview, which is one of the 12 interviews highlighting the diversity and minds of hearts and minds behind the fantastic world of clay mineral research and application. So this series of interviews is one of the many activities that the CMG has been organizing and coordinating, celebrating the Clay Minerals Group's 75-year jubilee this year. And on behalf of the CMG, I'm inviting you to celebrate with us. So to keep you informed about all that is going on during the Jubilee year, follow us on Twitter or LinkedIn, sign up for the Jubilee newsletter, and check the schedule of activities and events that are available on the group's website. So that's minersoc.org/CMG. But that was enough of an introduction and strapline here. So what we're really going to do today is have an interview with Yael Mishael, and it's my great honor to introduce her to you. And she is also this year's George Brown Lecturer of the Clay Minerals Group. And Yael will deliver this lecture at this year's International Clay Conference in Istanbul, Turkey. And later on, it will also be published as a review paper in Clay Minerals. So Yael is an associate professor and director of the Sustainability Center of the Hebrew University of Jerusalem. And she has been very loyal to this institution where she studied chemistry and structural molecular biochemistry for her undergrad. Then she completed her MSc in agriculture there and also investigated the absorption of surfactants on clay minerals for her PhD. She then spent some time at Purdue University as a postdoc before returning to the Hebrew University of Jerusalem as a lecturer, senior lecturer, or what might be more well-known assistant and associate professor. So Yael, it's great to speak to you today, and congratulations on being the 23rd George Brown Lecturer.
Thank you. Good morning.
All right. So as this year's George Brown Lecturer, which is a clay mineralogist, academic or industrial, recognized as an authority in their particular field, could you comment on your route to becoming a clay scientist? So who inspired you and how were you introduced to the world of clay?
Okay, so as you mentioned, I did my undergrad studies in chemistry, and I actually had a roommate that was a geologist, and she convinced me to take a course in geology. And so I did. And then it was my third year. And then I was introduced to clay minerals, and it was love at first sight. And then I was looking where I could study more about environmental chemistry, mainly its surfaces. And as we all know, clay surfaces are the most fascinating and exciting surfaces within the soils. And that's how I got to the Faculty of Agriculture, and I'm at the Department of Soil and Water. And I started my master's here with the clay mineralogist that unfortunately passed away at age 52, very young. Professor Leon Margolis, and then I continued my master's and PhD with Professor Shlomo Nir, that he works more on modeling, and I did the experimental part, and as you mentioned, on surfactants. And the rest is history.
Oh, that's very interesting. So very much a serendipitous encounter with clay minerals that basically made you have a career in clay minerals. That's fantastic. Thanks for sharing that. So you started with surfactants and interactions with clay minerals. Is that still your current interest, or has it moved away from it? What is your current interest in clays?
So I still work on modifying clay minerals. So not only with surfactants, we use a lot of polyelectrolytes, proteins, etc. So in the past 15 years, we've expanded beyond, but it's the same concept of how do macromolecules absorb to clay minerals spontaneously, and also we've been working on some grafting to the surface and from the surface of macromolecules, and for various applications. But first studying the basic interactions and then taking it from there.
Okay, brilliant. So do you think that, well, it sounds like, taking it from there, there's still a lot to learn about them. So what are the big clay questions that are still to be answered, in your field or, further afield for clays?
So thank you for that question. So after like 15 years of really studying clay modifications and different properties and trying to characterize the different structures at the clay surface, in the past 5-6 years, I've looked at a bit different questions, looking at self-assembly of clays or their role in soil structure. So obviously, the clay minerals have a huge role in soil structure, and those so in the past 5-6 years, as I mentioned, we've been looking more into basic science questions in situ, in the soil. How do soil aggregates come together? What are the processes? And what mainly, since I'm a clay scientist, what is the role of clay minerals? Which clay minerals, the effect of different parameters like salinity, wetting and drying, biological parameters, how did they affect the self-assembly of soil aggregates?
Wow, that sounds very complicated, if not complex, to find out the role of just one of the many participants in that. That also sounds like, it's going away from targeted applications to really understanding the larger role of clays in the world. So do you think there are any global challenges that clay science can help to address?
So as you mentioned, I'm currently the director of the Sustainability Center of UG, and it got me thinking about a lot of grand questions about our planet. And I think soil scientists do have a big impact and can contribute a lot to the basic questions there. A lot of the issues like the fate of phosphorus and nitrogen are two main issues. So obviously clay minerals play a big role there. I don't have to go back to basic the absorption of phosphorus to clay minerals. And land degradation, soil erosion. So I think as clay scientists, we should go forward and try to help these answer questions, again, back to basic science and applications, looking into these questions that are on the mind, I think, of all scientists in the 21st century. Mm-hmm.
Brilliant. So yeah, it's quite intriguing that, the university has a sustainability center. So can you maybe just quickly tell us something about that center and also how you ended up to be its director? And, congratulations on being director.
Okay. So we're actually celebrating our first year since we launched the center in a day or two. And it was actually top bottom. The president of Hebrew University decided to build up the center, and Hebrew University is the largest university in Israel, and it was my first task was like to bring together under one umbrella all the different activities. And when I mean activities, so we ended up clustering them into three pillars: teaching. So we have undergrad and graduate programs, and now we started a new program for like credits, for like a package of credits for undergrad students in liberal arts, humanities, law, business school, and social work, in the School of Social Work. So we have like a bundle of courses there. And then we have research, obviously, is the second pillar, where we fund and bring in funding and help support interdisciplinary research across the university, and also some international partnerships. And the third pillar is making a difference. So more outreach activities, also with decision makers, with the public. We have a lot of citizen science and such activities. So that's the center in like 5 sentences.
Yeah, no, that's great. It's really interesting, to see how that, how it takes shape over the next years. Yeah, that will be interesting to see. Lovely. Thank you so much. So maybe coming back more to you and your research career. So could you maybe share with us, I don't know, your proudest moment or your greatest satisfaction or the best clay decision of your research or career, other than following, obviously, your roommate's suggestion to take a geology course?
So I don't know if there's a specific moment, but I would say the great moments or the best moments, I think, of being a professor, generally speaking, are my interactions with the students. So when they come to me or even send me by WhatsApp, a picture of a figure that they just created and they're all excited that the results came out the way we thought, or if they come and they ask some questions, why does it work this way and why does it work that way, and so on. So I think those are the best moments when they're as enthusiastic as I am. I would say those are the most exciting moments. And we had 2-3 years ago a PhD of mine, Maoz Dor, now he's a postdoc. We were studying the effect of salinity. So he was one of my first PhD students who was working on soil assembly or soil self-organization. And we were looking at the effect of salinity on 3 different clay minerals, on kaolinite, on berylonite, and elite. And very basic experiment, adding different concentrations of calcium chloride and looking at the organization at different scales, at the nanoscale, looking through cryo-TEM, and looking at the micron scale, so cryo-SEM, looking at the organization and alignment. And at the cryo-TEM, so it's very hard to, as I think all clay scientists knows, it's very hard to get images of the 001 diffraction. We always see it flat, and we wanted to see, as we measure with X-ray, we wanted to get the difference. And they worked for a long time with the microscope, and then they could tilt the sample itself and get so we saw the distances. And like that first image, he was working in a microscope, not on campus, and he like called me and sent me pictures from the screen and was so excited. And yes, it was an exciting moment to see his enthusiasm.
Right. Yeah, I can feel the enthusiasm coming over the internet even now. So that's great. So, but enthusiasm and success is always, very closely related also to work that failed. So maybe do you have an example of that where your work failed to produce the results that you had hoped for, and maybe, even turned it into something that was really interesting and insightful in the end?
So so recently we had, so most of my projects actually that we work on, so as everybody knows, you write grants all day and hope to get funding, and then a very low percent is funded, and then you eventually work on these grants. But in between a lot of my work and a lot of my students didn't work on a specific grant. We put in bits and pieces, and the most fantastic projects usually came out of those more creative and not written down structured projects. But like 2-3 years ago, I actually had a very structured project that got funding, and I think that's why it failed, because it was too organized. And we were trying to look at the absorption and oxidation of a small organic molecule, a gasoline additive, MTBE, on zeolite, a modified zeolites, not clay minerals, but a cousin. And we kept failing and failing, and it was like a 3-year project, and we couldn't figure it out. And in the end, we gave up. So I think that sometimes working too structured, when you have very clear, or at least for me, very clear goals and aims, and you think everything will work exactly as you planned out, is not the way for me to work.
Okay, so here's a pledge for more open, creative experiments rather than planning everything out. Yeah, I can agree with that. That's interesting. Lovely. So I think we all have our little pet clay. So, you also venture a bit further afield, going to zeolite, and maybe even layered double hydroxide. So what is your favorite clay and why?
Well, I wouldn't say I have a specific favorite, but the ones that are less explored, I feel like they're a bit, left out. So so all the more rare, we usually study the more common clay minerals. So like they have rare diseases, that some physicians then study. I feel like we should have the rare clay minerals that someone should pick up and show an interest. Yeah, one day. Yeah.
Yeah, that would be an interesting study to see how they are different. Yeah. Okay. So you seem to be very enthusiastic working with students, and I think that's mostly, any student, but you've given examples of PhD students and postdocs by now. But when you look back to, when you were starting out with your roommates telling you geology might be something for you, or, early career research starting their career, could you give them some advice?
So as you mentioned, the word enthusiasm came up several times. Yes, I'll use a similar word, but not exact. I think you need a lot of passion for any science. So clay minerals doesn't sound like, solar energy or cancer, one of the most, but any science, I think you have to be very, very passionate and curious and want to figure out, it's a puzzle. And basically you want to figure out the basic questions. And then you'll see each one can take it to wherever he wants, if it's a basic science, if you want to study some applications, or if you want to whatever. But I think you have to be passionate and curious in order to have a career in science.
Okay, yeah, I would fully agree with that. At times it's not so fantastically, overwhelmingly positive all the time. So the gloss over those lower moments.
Ups and downs. But
exactly. So, but other than clay minerals, I guess you also do something else. So when you're not working on clays, what do you like to do?
So I'm a mother. I have 3 children in a family, so that keeps me busy. My kids are older by now, 22, 20, and a younger one, 14. So so a cliche, but the balance of work and a career is still in the background and still challenging, but highly recommended, both the career and family.
Yeah, very good. Yeah. So that basically fills a day with 3 children. I can just guess. Yeah, lovely. So, the last question is maybe a bit of a, inspiration for us doing these interviews to, look for new interviewees. But if you were to interview someone, who of your clay heroes or heroines would you like to interview?
Whoa, so that's a hard question. So I don't want to insult anybody, and I won't go backwards, okay? So it won't end up favorites or anything. But on the contrary, so maybe I can show. I'm just now check. So it's in Hebrew, but I'm checking a test on soil formation. So I get all the answers from all the students, and we go through the clay structures and clay, obviously. So there's a lot of clay. About 20% of the course is going through the different clay minerals and their structures and etc. And there is, every year I have like my favorite student. I won't mention names, but in the course of soil formation. And like from their answers, I can already see, back to that point of inspiration and enthusiasm, that there's one student like kind of gets it, he's not just memorizing the CC and the surface and etc. and just pouring the answers back to me in the exam, but he actually, says, well, I think I may, why don't we, this is unknown and etc. So every year I have like the student where I can tell that he has this like little sparkle in him, that in their answers. And I would like to interview that student, or maybe even give him her a little push towards continuing or pursuing a career in clay science.
Yeah, well, why don't you do that? You don't have to record it on Zoom and put it onto your YouTube channel like we will do. But yeah, that might be a nice inspiration for them. Yeah. Lovely. Well, thank you very much for, answering all of these, I don't know, hard or unexpected questions. And it's been a great pleasure talking to you. And I'm very much looking forward to listening to your George Brown lecture very soon indeed.
So I will see you then. Thank you.
Brilliant. Thank you very much, Yael, and all the best.